Hello everyone, in this video we are going to see the introduction to COFF file format and the beacon object file. So the COFF common object file format is a file format used for storing compiled code such as that outputted by a compiler or linker. Like most compiler file formats, COFF defines structures to store the information of the file about the sections of the program such as text, data, etc. So if you know about the PE file format, the exe, if you have watched my previous video or courses, you can see we have written a PE loader. So it contains various headers, DOS headers, signature, section headers, imports, exports, etc. In the same way, the COFF also contains a file header, optional header, section headers, relocation table, symbol table, string table, etc. So Microsoft has taken this COFF and developed a PE file format. So that is why you can see the names are being familiar. So we'll be seeing all of these headers, how to parse them, how to fix the symbols in this course. So beacon object file, so the COBA strike, you can Google search for this beacon object file COBA strike and you will get this link. So this was introduced in the COBA strike 4.1 in 2020. So what is the usefulness of this beacon object file is it helps to run a small piece of code within the memory without creating a new process. So this BOS have been written in C and we can write in C++ as well. So if you want to get the DC name or DC IP address, you can use this function ds-get DC name A and immediately you can print the output or error based upon this function output. So in your C2 framework, you can write your BOF that does some functionality like retrieving the domain controller name, domain controller IP address, or enumerating users, etc. Like a small piece of functionality you can implement that runs inside the memory of the beacon. So using C++ to write the BOFs. So here we are going to resolve this dynamic function. So the loader does not know how to resolve a get DC name A function. So that is why they have implemented a pattern that is the DLL name dollar the function name. So the loader, upon seeing this dollar symbol and identifying it as an external symbol, it will then resolve based on the string. It will split the string based on the dollar, and the left part is the DLL name and the right part is the function name. So it writes the DLL and use the getProc address to get the function address of this ds-get DC name A and execute this function. So that is the theory. So we are going to see this declare spec import in the end of this series, end of this course. So for now I'm going to show you how to write a small code. So you need to create a new C++ project. So you can include Windows header file, so we can get the definitions of Windows API. So the symbols, the object file contains the symbols and the section code. It does not know the main function. So in the PE file you have an address of entry point to execute the main function code, but here we have only symbols. So we need to assume a symbol that as a main function to execute at that point. So that is where they have decided as a go function. So we are going to make this as a C, extern C void go function. So this function can be treated as an entry point to our code. Now you don't need to implement this function resolving here. What you can do is first, before that, we are going to download a COFF loader from the trusted sec. I have already downloaded this, cloned this repo. You need to have a Linux to generate these files. So you can run this python 3 beacon generate.py, and you can see you will get these COFF loader 32.exe and COFF loader 64.exe. So before that, for writing the BOF code, you do not need any of these. You don't need to declare this function name, symbol name like this. What you can do is you can actually use the functions load library and load the user32.dll. Yes, so this is now our BOF code. This can be treated as a BOF code. So whatever we write here, it should be position independent. You should not use any vectors or something like that. So yes, this is our sample BOF code. So let's go and open this project in a folder, and now you will see the BOF test.cpp file. So what you can do is type the x64 native tools command prompt and copy your directory path and cd, and here we have the cpp file, so we can use the cl.exe. so the linker will output the object file. So we the COFF loader, in the sense, we are going to act as a linker and produce a object file, not an exe file. /gs disable the security cookie /c, and output format is bof test.o. .o is the extension, and now specify our cpp file. And now you will see bof test.o object file. So we can use the dump bin command to dump the symbols of the bof test.o. So these are the symbols, and here you can see an external symbol __imp _load library a, and also another one that is external go function. So you can see there are two symbols, external symbols, go and load library a, and this $static can be this string user32.dll. So these are the symbols we are going to resolve in the future videos in this course. So these are the symbols that our code requires, and now we are going to dump the assembly code for our text section, that is dump bin section dot text $mn. So this is the section we are going to dump /raw data bof test.o, and now you will have this raw data. So copy this and type hex to assembly in Google search, and you will see this website. So go to disassemble and paste here, and remove the ASCII characters and this address. Make sure you only have the opcodes. So disassemble, and here you can see the assembly code for our opcodes. So the first one is the making the stack space for our variables, and now here you can see, so this is the first parameter, because the call is a call to a function, and RCX in the Windows calling convention, RCX holds the first parameter and RDX holds the second parameter. So we are loading something inside the RCX. So what is that something is the user32.dll. So these 4 bytes must be filled with the offset to the user, that is the DLL. And call keyword pointer RIP plus 0. So we do not know the address of load library A function, and we need to fill these 4 addresses with the symbol address of this load library A with the offset to the function. So we need to fix these two symbols and execute this assembly code, and basically it is executing our BOF code. So I think you have understood now. So what we write here, it goes into this disassembly, and we will have these placeholders for these symbols, and we need to fix these symbols and execute the go function. So that is the logic behind this. So okay, let's test this one. So what you can do is h module user32 handle. So we are storing this in a variable, and if this user32 handle is a valid handle, meanwhile you can execute this BOF test.o, and we need to specify the go function, and it has executed our COFF file. You can see it got the contents of the COFF file, running the COFF file and parsed the COFF file, but we do not see any output because we haven't done anything. So we are going to retrieve the address of message box A. So message box address, we have retrieved the message box A address. Now we are going to treat this as a function pointer. It returns an integer, and it takes the parameters HW handle, constant char star, and the uint. Now this message box address is of the function pointer of type this function signature, and now pass in our variables, pass in the parameters, let's say hi and 0. Now let's go and compile this one. Now if you go and check the symbols using the dump bin, you can see there are 2 more symbols, one more symbol get proc address, and there are some other variables, the static. So these variables are pointing to this. Now if I go and dump the raw data, so you can copy this raw data again and paste here. So here you can see this is the code where we have zeros. Here you can see zeros. We are loading something into RCX and calling the function. You will have zeros. We need to fix these symbols. We are going to do that in this course. So this is the assembly code. So okay, now what we can do is you can actually run this one, go function BOF test.o, and here you can see our BOF code has been executed successfully, and you can see the message box pop up. So you do not need to follow this convention like this one to execute your BOF code. You can actually write the code like this using the fetching the function pointers and executing the code, but this simplifies the process of writing the code, because you just declare the function, and using the DLL name, $function name, the loader will automatically uh, splits the string and loads the DLL and fetches the function address for you. So that's all for this video. We have seen an introduction to COFF and the beacon object file. In the upcoming videos, we will see the format of COFF file and how to fix the symbols and execute the go function.